So here are 3 problems that I didn't get to in our help session today, and I wanted to go ahead and post a little video for them. Here we want to know what happens to the rate when NO is doubled and H2 is cut in half. And the rate law is given to us right here. And I want to just compare. We know what the rate is, but I'm not going to worry about that number right now. I want to compare if this is a 1 and this is a 1. This is going to equal K. All right. If I were to double the NO and cut this in half, then I end up with 2K. Right? 4 divided by 2 is 2. 2K. So whatever the rate is here, the rate here is twice as big. Okay? The rate is doubling because of this. So if we knew that the rate was 0.042, under the first set of conditions, doubling the first one and halving the second one will double the rate, and it will be 0.084. The next problem is a solution problem where we're trying to figure out the molar mass of an unknown. We don't know what it is, we can't go to the periodic table, but we know molar mass is grams of the unknown per mole. In the problem, they told me that they weighed out 5 grams of this unknown. So if we could figure out how many moles we had in that sample, we'd be set. They took that 5 grams and put it in carbon tetrachloride, and they saw that the boiling point of the solution increased from 76.8 up to 81.5. And so that is going to tell me we're going to use the change in temperature of the boiling point problem. Okay, so what was the change? It's 81.5 minus 76.8. Okay, that's the change in temperature. The KF is given to me in the problem. It's 5.02 degrees Celsius per molal. Since it is a non-electrolyte, my I is 1, and what I don't have is the M. So I'm going to take these values and solve for M. The change in temperature is 4.7 degrees Celsius, and we divide by 5.02 degrees Celsius per M, and that will give me 0.904 as the molality. Well, what is molality? It is moles of the unknown divided by kilograms of the solvent. Well, I just want the moles. I don't want this kilogram coming along for the ride. So I look up here and see that they dissolved in 25 grams. So if I multiply by 0.0250 kilograms of CCl4, I will know just the moles. And that is equal to 0.0226 moles of the unknown. So now I've got the bottom number, 0.0226. So 5 divided by that number is 221 grams per mole. This next problem is a conversion between concentration units. We are given that it's 39% by mass of HCl, and we're asked about the molarity. So when I'm given a problem like this, I will take the unit they give me and write it out as the fraction it is. It's 39 grams of the solute HCl divided by 100 grams of the solution. That's what percent means, per 100. And I'm trying to get it to molarity, which is moles of HCl per liter of solution. Work with the numerator and the denominator separately. For the numerator, we're going to take the grams of HCl and we're going to use the molar mass of HCl in order to convert to moles of HCl. The molar mass is 36.46, and that gives me a moles of 1.07. And now the denominator. The denominator is 100 grams of solution. That's a mass. We needed to get to volume. The job of density is to get me between mass and volume. So I don't want grams of solution. And notice it tells me this is the density of the solution. I want milliliters of solution. I put my 1.20 there. And then I take it one step further from milliliters to liters. Milli means 10 to the minus 3. And I take 100 divided by the 1.2 and times the 10 to the minus 3, or divide by 1,000. And that's 0.0833 liters. So now I've got my two numbers I can plug in. We have 1.07 moles and 0.0833 liters. And that gives me a value of 12.8 molar.